on these, let's take a look at the first one. Are you able to isolate y on the first one? What do you think?
Yes.
Yeah, you are.
Yeah.
Multiply both sides by y cubed, and you end up with x equals y cubed. So what does y equal? X to what power? 1/3. You can write that as cube root, but here's the thing. If we're going to differentiate, which is what we're going to do now, is it better to have it in radical form or in exponential form? Because you have to drop that number down, right? It's much easier to do. So what is y prime going to be, Liebarger, if I take the derivative?
1/3 x minus
Liebarger, yes, to the?
negative 2/3.
Yeah, done. There it is. Now, it's debatable whether, some people say they don't like having negative exponents. So if you don't want to write it in negative exponents, that would be 1/3 times x to the 2/3. Are these the same thing?
Yes.
Is it arguable which one is simpler? Sure. I mean, think about it. Yeah. Is there a negative exponent there? Sure. But what's in the other one that isn't in the first one? A fraction, right. Personally, I don't really like the fraction, so I keep it in the flattened state. But it kind of depends on your handwriting. You know, do you use a lot of parentheses? You have to be careful. Some people write it really messy, and they write like this. Is this true? No. The negative 2/3 is either 2/3 on the bottom or positive. Okay. That wasn't so much work. Do you agree?
Yeah.
So let's use implicit differentiation and see what happens. If we use implicit differentiation, we're not going to solve for y first. We are not going to solve for y first. What is this? Can someone tell me what that is? It's a fraction. What's another way of saying fraction? It's the name of one of our what? It's a quotient. So what rule would we have to use? The quotient rule. So this is regular differentiation. Let's use implicit now. If we used implicit differentiation, can you tell me what's the lower function on this one? What's lower? Y cubed. What's the upper function? So it's going to be low times the derivative of the high. What's the derivative of x?
1.
Low d high minus high, the derivative of low. What's that going to be?
3x squared.
Y squared.
3y squared.
Times what? This is important. Y prime. Because y is a function of x. The way we can think about this is as follows. Let's go back. Let's rewind a second here. This is the same thing as writing x over some function to the third power equals 1, where y is equal to f of x. Let's write it like this. Is it okay if we do that for now? Is that okay? This will help us because, remember, it's low, f of x cubed, d high, minus high. Again, what's the derivative of low? Let's do this again. It's the same thing. What do we drop to the front? The derivative of low. 3 times f of x to the squared times what?
F of x.
F prime of x. What rule did we just use? The chain rule. It's not x. Well, there is an invisible number here. There's that 1, right? But over here, when we took the derivative of this thing right here, when we took the derivative of the bottom, we had to use the chain rule. What's the inner function? F of x. What's the outer function?
X cubed.
The cubing. So we drop the 3 to the front, we change the 3 to a 2, and then we have to multiply by the derivative of the inside. What is the inside in this case? F of x. And what is this over? What's that over?
F of x cubed.
F of x squared. And what does that equal? Well, the derivative of 1 is 0.
Wait, would you
Right.
do?
Kids, we're doing the derivative of the left and we're doing the derivative of the right. What is the derivative of 1? 0. What's the derivative of any fraction to equal 0? What has to be true? Y cubed minus, and let's just make it a little better. What is it? 3x y squared y prime has to equal what?
0.
0. What can we factor out?
Y squared.
Y squared. You get y minus what?
3x
Y prime equals
0.
0. So there's one solution, which is when y is equal to 0. Do you agree with that? Okay, let's look at the other one, though. That's when y minus 3xy prime is equal to what?
0.
Do you agree with that? So y prime is going to be negative y over negative 3x, which is y over 3x. So we just got y prime is equal to y over what? 3x. And that doesn't quite look like what we got before, because what is in this right there? What's in there? Both
X and y.
x and y. What do we not really like that's in there?
Y.
We don't really, well, the 3 is actually fine. We don't like the,
Y.
we don't like the y. We like the derivative just in terms of x. What was our original equation? It was x over y cubed is equal to what? 1. So that told us that y cubed is equal to x, which y is equal to x to the what? 1/3. Do you agree? Remember, this is the original equation, right?
Yeah.
So what can we replace here? We can take this and plug it in for y, and what do we end up with? Y prime is equal to 1/3 over 3x. Sorry. Over 3x. So what does that equal? 1/3 x to the what? Did we get the same thing?
Yes.
That is the exact same thing, but here the only thing I want you to take away from this is the following. Well, two things. One, when you take the derivative of y, you get y prime. When you take the derivative of x, what do you get? When you take the... Oh, thank you. Thank you very much. Kids,
X prime.
you get x prime, which is 1, because we're doing our derivative with respect to x. But here's the thing. We kind of cheated because I said we're not going to isolate for y, but what did we just do? If you can isolate for y prime, and if you can isolate for y, what can we take? We can just do the derivative right now. That's what we did before. Or you can do blah, 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 blah. So in this case, what was a lot easier? Regular method. So here, the big moral here is if you can easily isolate y, differentiate that way. Are we okay with that statement? If you can easily... We good? Okay. Let's do another example.
I just get rid of 3x there.
I didn't get rid of it.
What is
X to the 1. 1/3 minus 1 is negative 2/3.
Okay.
X to the 1/3 over x to the first is equal to x to the 1/3 minus 1, which is x to the negative 2/3.
What happens to the 3 then?
It's right, it's still there. The 3 is not being raised to any power.
Okay.
Where's the 3? The 3 is right there. It didn't go anywhere. See the 3 right
so
there?
It's 1/3 x over 3.
1/3 times x over
Yeah.
to the negative. It's this now. Like that. It's not in the denominator anymore. Okay, so let's do another example. Here we go. Let's do number 2 here. What does this one almost look like? It almost looks like a circle.
Yeah.
Very good. It almost looks like a circle. So you think to yourself, well, hey, the work must be similar. It's actually much easier. In this case, what can you easily isolate? You can't
Y.
easily isolate y. What's your first step? What do you subtract?
X squared.
X squared.
X squared. So you get y cubed is equal to...
Minus X squared.
So y is equal to 4 minus x squared to the 1/3. Now if we want to take the derivative, what do you get? Chain rule. Yeah, the inside-outside chain rule. Very good. I like that. Inside out. So 1/3, 4 minus x squared to the
Negative
2/3 times what?
-2x.
Negative 2x. So you can clean that up a little bit. This is how I would write negative 2x over 3 times 4 minus x squared to the negative 2/3. That's about as easy as it gets. So if you can ever do it that way, is that great? Yes. You can be pretty confident in your answer. Can you use implicit on this? You can. It's actually not that bad. Let's use implicit. What's the derivative of 2x? Oh, what's the derivative of x squared?
2x.
2x plus 3y squared y prime, because you have to use the chain rule, remember? Equals what? Equals 0. What are we isolating now? Y prime is equal to negative 2x over 3y squared. But what do we not like in there? We don't like the y squared, but what do we know y equals? Again, this is where we do what we said we weren't going to do. We like y. Because you really can't easily solve for y on this one. No. Really no. You have y to the 7th, you have y cubed. Do you want to solve? No. That being said, some of these that look terrible, there might be some like really cute manipulation you can do. But here's the thing. When you look at that, you should immediately think implicit differentiation. Immediately. So if we do that, no, you can't. There's no easy way. There is a way. It's not very easy, though. It's not nice. So we're going to use implicit differentiation. We're going to differentiate with respect to x. What's the derivative of x squared with respect to x? 2x. That is correct. That's the first part. What do we now have to use for the second term? What? You must use the product rule. What are the two functions? X and y. What's the derivative of x? 1 times y plus x times y prime plus what? Someone raise their hand and tell me what's next. What's next, Andrew? 2y y prime equals what? 0. This right here, I'll highlight it, everybody. Here's the derivative of that. Here's the derivative of that. And here's the derivative of that, right there. Take a look at that. What did we have to use for the yellow, everybody? That's the product rule right there. Everything else, and this you'd have to use the chain rule right here, and this is just nice regular, I'll call that. There's one more. What's a simple mistake on the outside that people make? What's the derivative of 5? 0. What do people make the mistake of doing? Keeping it as 5. Does that mess everything up downstream? It makes it so you can't simplify. So if that's true, what do we now isolate? So we have 2x, I'll just write this out, plus y plus xy prime plus 2y y prime is equal to 0. What do we isolate? Y prime. So we have xy prime plus 2y y prime is equal to negative 2x minus y. So y prime is going to equal negative 2x minus y over x plus 2y. And you are done. You're absolutely done. No, it really isn't. The thing that makes it hard is making simple errors. The problem is can the algebra be a little tricky? It can. What happens to the algebra if you kept the 5 right there? It's just flat out wrong. I mean, for example, I just asked you for the derivative here. What happens if I ask you to do something with the derivative and there's a 5 there? Everything else is going to be wrong. So here's a question for you. Here's the derivative. Here's the original function. I could ask you, here's that original function. Where is it? It was right. Oh, it's right here. I made it up. There it is. I could ask you, where is the tangent line horizontal? What does it mean if the tangent line is horizontal?